(2011) paper 1, let's have some fun. It says, without using a calculator, find the exact value of the square root of 75 plus the square root of 12, all square minus the square root of 75 minus the square root of 12, all square. So let's do this without our calculator. All right, so it's the square root of 75 plus the square root of 12. We want this all square minus the square root of 75 minus the square root of 12. Now there are two ways you can do this. You can actually expand the bracket and work it out. But if you want to show off some skills, you can show them, say, look at this. This is the difference of 2 squared, don't it? If you look at it, you realize that all of this is like a and all of this is like a b, though. So it's like a squared minus b squared, right?
Yes, sir.
So we can tell them, so because of a squared minus b squared, this would be equal to a plus b, so it would end up being root 75 plus root 12, that's a, plus a b now, plus root 75 minus root 12, that's a plus b, then this is being multiplied by your a minus your b. Your a minus your b would be root 75 plus root 12 minus b now. Minus would be minus all of this. So it would be minus root 75, and then minus and minus become plus. So then this would become plus root 12, right?
Yes,
you agree
sir.
with this? Nice. So all we need to do is simplify this now. As you can see right here, so look at this, root 75 plus root 75, that's 2 root 75. That's 2 root 75. Then we can say root 12 minus root 12, that gone down. Then they cancel, right?
Yes, sir.
And then over here, so root 75 minus root 75 gone. And root 12 plus root 12, that become 2 root 12. So end up get 2 root 12. Now, Marika, it said we're not supposed to use our calculator. So we can't even put it in our calculator here. So what we have to do then is say 2 times 2 is 4. Then we'll get 4 times the square root of 75 times the square root of 12. Then we have to use thirds and break this down. 75 is 25 times 3. So we can write this as 4 times the root of 25 times the root of 3. They have to remember that 12 can be broken down as the root of 4 times the root of 3. Now the root of 25 is 5, so that going to become 4 times in bracket 5. And then root 3 times root 3 is 3. And then root 4 is 2, right?
Yes, sir.
So we have 4 times 5 times 3 times 2. And look at that. 4 times 5 is 20. 20 times 3 is 60. 60 times 2 is 120. That's our answer. You just write nice. Right? You just tell them nice. That was a nice way to start the paper. Right?
Yes, sir.
Nice. So of course, you know our style, we always check the answer. So we just get 120 without the calculator. Now we're going to actually put it in the calculator just to verify, because sometimes maybe we make an addition mistake somewhere. We can always put it in our calculator to verify we didn't do anything wrong. So let's do that. So put it in the calculator, root 75 plus root 12. Get the square root 12 square minus in bracket root 75 minus root 12, close that bracket, square, put it in the calculator, so 120 there. See it? right? We call it this. Are you hearing me, Marika?
Yes, sir. I just have one question, sir. Can you go back to it?
All right, no problem.
So, you expanded the brackets. I understand that.
Well,
And
we didn't expand the bracket. What we did was look at it as a difference of 2 square. So the difference of 2 square formula tells us a square minus b square is equal to a plus b times a minus b. This is the formula that we use, sharp, because I'm telling you that 99% of the Caribbean won't do it this way. So we want to
yeah,
stand out.
I wouldn't think of doing it that way.
All right, so this sharp, right? So we look at all of this part as A and all of this part as B. Yeah?
Okay, so but if you, I understand as that's A and that's B, but if you have 75 plus 12 plus 75 minus 12,
So it's root 75 plus 12, yeah, plus root 75 minus root 12, yes. A plus the B, close up that bracket, and multiply it by the A minus the B.
oh,
And
that's
then right here, so we did realize that this root 12 and the minus root 12 will
root 12
cancel.
cancel,
Then
which leaves back the
this,
75.
yeah,
But if you have 75 plus 75,
that's just 2 times root 75.
yeah.
And then this one is just 2 times root 12. Then the 2 times the 2 give it a 4. They'll just put up a root 75 times the root 12.
Okay, I get it. I wouldn't think of doing it that way. I don't think that would have come to my mind.
You'd have probably just wanted to expand the bracket, right?
Yes,
Yeah, but
that's what I would have done.
we want to show off some skills. So we're showing them that we know the difference of 2 squared.
Okay. It's just sometimes you don't see
Yeah.
to use it because it doesn't look
Yeah.
like it's that form.
Yeah, I understand. All right. Now let's move on now. We have this right here. So now 27 to the quarter times 9 to the 3 over 8 times 81 to the 1 over 8. So let's do this quickly. It says we have 27 to the quarter.
So which paper is this?
Oh,
Which year?
this is 2011. All right. It's in the second set. It's in the second.
Today, right?
Yes, it's in unit 1. It's in the second set of papers that I uploaded, the 2005 to 2015. It's on page 130. All right. All right, so we have 27 to the quarter times 9 to the 3 over 8. And we multiply it by, what was that right there? 81 to the 1 over 8. And it said do this without calculator. So of course, we're going to use laws of indices. So first thing we have to do is change everything to one common base. So we can rewrite 27 as 3 cube. So it's 3 cube raised to the quarter. And then this would be times 9 to the 3 over 8 is 3 square raised to the 3 over 8. And then we're multiplying that by 81. We can rewrite 81 as 3 square. Wait, 81 is what? 3 to the 4? 3 to the 4 to the 1 over 8. And then now what we need to do now is remember by laws of indices, if you have a to the p raised to the n, it's equal to the a to the p times n. So using that law, this is going to become 3 to the 3/4 multiplied by 3 to the 2 times 3 over 8 is 6 over 8. So that's 3 to the 6 over 8 times, this is going to then be 3 to the 4 times 1 over 8, which is 4 over 8.
Sir, you wouldn't want to simplify it?
So now we're going to simplify it now. Whenever the bases are the same and we're multiplying, we can add the powers. So now this is just, remember 3/4 is really 6/8. So this is just 3 to the 6/8 plus 6/8 plus 4/8. Right? We can add the power since the base is the same, right?
Oh, yes.
So now we just add the powers easy. 6 plus 6 is 12, plus 4 is 16, and we have 16/8, so that's 3 to the 16/8, but 16/8 is 2. So this is just 3 square, and 3 square is 9. Imagine the question work out so easy, nice, right? You just tell them nice. That work out to be 9, right? So just tell them that's nice. We just get 9, right?
Yes, sir.
All right, so again, as I always say, you want to verify your answer. So anytime you work out a question, we can't tell them nice and we make any blemish. So just have to check if it's correct. 27 raised to the quarter multiplied by 9 raised to the 3/8 multiplied by 81, and we raise that to the 1/8. So we do that now, and we'll get 9, see it? 9. So all of that, and we'll get 9, so we're nice. So now we're good, and we're done with that part. 3 and 3, we're gone 6 marks. All right, so we're cool with that?
Yes, sir.
All right, now part B now is polynomials, and they give us a graph this time of the cubic function. All right, they tell us that the diagram below is not drawn to scale, and they tell us that it represents a segment of the graph of the function x cubed plus mx, m times x squared plus n times x plus p. And they tell us that m, n, and p are constants. They say find the value of p. What do you think is the value of p? What does p represent in a function? When they give you the graph of a function, what does the constant represent? What does the constant represent?
The y?
The y-intercept, exactly. So see it here. The y-intercept is what?
The y-intercept is 4.
Exactly. So p equal 4. Nice. So then give it p already. So can tell them, all right, nice. So get p. We're nice. All right. Now they tell us to find the values of m and n. There are two ways you can find the value of m and n. All right. The first method you can do it is by factor theorem. All right, and the next way is by sums and products of roots. All right, so we're going to do it both ways, and you will decide which way you'd want to do it in an exam. Now, based on the graph right here, they're telling us that x equal 1 is a root and x equal 2 is a root. Remember, roots are where it cuts the x-axis. So 1 is a root and x equal 2 is a root. So if x equal 1 is a root, always remember this from factor theorem. If x equal 1 is a root, then f of 1 is equal to 0. And also, if x equal 2 is a root, then we know that f of 2 is equal to 0. Also, given that we've identified m and n, we end up have a simultaneous equation, because this is f of x, x cubed plus mx squared plus nx plus 4. Oh no, p is 4. So all we're going to do is set up equation by plugging x as 1 and 2. So f of 1 is going to be x cubed, which is 1 cube, plus
Plus n plus
plus
n plus 4 is equal
m,
to 0.
m times 1 square plus n times 1 plus p, and p is 4, and that equals 0. Yes. So then now we set up an equation, and we have m plus n, and then we realize it, we see that 1 plus 4 is 5. So bring the 5 over here and write -5. So m plus n equal -5. They can set up a next equation and tell them, say, f
2
of 2
cubed
equal 2 cubed here plus
plus m times 2 squared
m times 2 squared plus
n times 2 plus
n
4 is
times
equal
2
to
plus
0.
4 equals 0. Very good. N plus 2 plus 4 equals 0. And then we have one boring
And,
simultaneous equation.
yeah, then you have 4m plus 2n is equal to negative 12.
Very good. 4m plus 2n is equal to negative 12. Then what we can do is, I know you like substitution, but
I can do elimination.
yeah, just multiply through it by 4 to get 4m plus 4n equal to negative 20. And then we can subtract the two equations. When we subtract them, what we get is, let me subtract it better. The 2n minus 4n, that's minus 2n. And then the negative 12 minus the negative 20, that's positive 8, right? Positive 8. So get n equal negative 4, right?
Yes,
Right?
sir.
And if n is negative 4, then m must be negative 1, because negative 1 plus negative 4 is negative 5, right?
Yes,
M
sir.
equal to negative 1. Yeah, man. So m is negative 1 and n is negative 4. So right here, so we can write m equal to negative 1 and n equal to negative 4. Now, Marika, look on the next sharp way now that we're going to do it. This is method 2. This is the nice way, right? So since we know
I
that
feel like
x,
there are other ways harder.
no man, it's not harder. Look what we're going to do. We're going to rewrite f of x in terms of its factors, its three linear factors. If if 1 is a root, then x minus 1 is a factor, though. Times, if x equal 2 is a root, then x minus 2 is a factor, though.
Yes, sir.
Right? And then look at this now. We know say it must be x times something. But look at this, Marika. If the n number supposed to be 4, if this n number supposed to be 4, right? Then we know say 1 times 2 times the next number for be 4. So the next number here is have to be positive 2. Tell me if that makes sense.
Yes, sir.
That makes sense, though? Yeah. So now remember, Marika, sums and products of roots. The sum of the roots would be minus b over a, right?
Yes, sir.
The sum of the roots is minus b over a. So look how easy it's going to be right here. So using sums and product, the sum would be minus m over 1. And then basically what I tell them, so the three roots are 2, 1, and this right here so is negative 2. So look how this one easy. We say negative m is equal to negative 2 plus 1 plus 2. That tells us a negative m is equal to 1 and so m equal negative 1. That's not much easier. This way not easier. This way easier, right?
No.
It's just that we don't want to remember the sum and the sum of roots and product of roots. Once you remember the formula, them easy, you know, minus b over a. The product of the sum is c over a, and the product of the three roots is d over a, right? We just need to remember those formulas and it's nice, man. And likewise, we do the same for n. We'd say that n over 1, which is c over a, is the product of the sum. But the product of the sum will have the three roots there. So it would be minus 2 times 1 plus minus 2 times 2 plus, that would then be, we have minus 2 times 1, minus 2 times 2, then 1 times 2. And then we work that out now, we get our answer. So this would just end up being negative 4. So see it there, n equal negative 4. You don't think this way short and easier?
I mean, I think so, but I don't know. I feel like I would stick to what I just.
With the factor, okay, I understand. Factor theorem, I understand, no worries. All right, and since we already write down the x coordinate of q, we can just put it right here. So x equal negative 2, that's the x coordinate of q. All right, you do that question there, you tell them Really? This is escape, you know. Ask them. Really? That's too easy, right? Tell them that's too nice. You can tell them that, you know, tell them that. And so that's too nice, right?
Yes, sir.
All right. Now let's go to the next one right here. And this one says now, by substituting y equal log to base 2 of x or otherwise, we're supposed to solve this log equation. So we need to substitute y as log to base 2 of x or otherwise, meaning if you think of something else, you can do it the other way. Now, since they're telling us what to do, why would we not want to do it that way? They must be giving us a hint.
Oh, sir.
Yeah.
How do you get -2 for q again?
Oh, we got -2. Remember we said that q is the x coordinate. Let me scroll up a little bit. Whoa. Why is it on text? Let me fix that. All right, how did we get q to be -2? Now remember we said that p is 4, right? We said this value is 4, agreed?
Yes, sir.
Now if this value is 4, we first write out the factors. We said that since x equal 1 is a root, x minus 1 is a factor, right?
Yes.
And x minus 2 is a factor, right?
Because the root is 2.
And then what we say is that the next number right here, so when you expand them out, when you multiply the 3 number them, it's supposed to give you back p, though?
Yes, sir.
And so what we say is the -1 times the -2 is +2. So 2 times some number right here, so must equal 4. But the only number we can multiply by 2 to get 4 is 2, though?
Yes, sir.
So now if we have x plus 2 here, so then that means the x equal -2 would be the root, don't it?
Okay, understand.
Nice, because if we set it equal 0, we get x to be -2. Cool with this?
Yes, sir, understand.
All right, nice. All right, now we're at this log equation now. So we're supposed to substitute y as log to base 2 of x. So go do that and see what we're gonna do. This is solve log to base 2 of x equal log to base 2 of root x. And they said we're supposed to call log to base 2 of x y. Now, Marika, we don't like to solve equation with roots, right? Especially with logarithms, that's going to be complicated. So what we're going to do is rewrite root as raised to the half power, right? Then we can raise all of this to the half power. Raise this to the half power instead of writing square root. And this square root here, so we're going to do the same. We're going to write it as half power, don't it? Make sense?
Yes, sir.
Nice. Now, remember they said that we can call log to base 2 of x, we can call that y, right?
Yes, sir.
Since we can call this y now, what we're going to be doing is we can carry down the power. So we can store y upon this side, carry down the power. So now we have a half y, half log to base 2 of x, right? Don't laws of logarithm, we can carry down the power and bring up the power if we want, right?
Yes.
And this is now y log to base 2 of x. Remember, this is a half, so just to keep it consistent, we're going to write back log to base 2 of x right here. But in the next line, we're going to substitute log to base 2 of x as y. So plugging in this as y, we're basically solving y to the half power, or you can write the square root of y to the half power, or the square root of y is equal to a half of y, right? That makes sense?
Yes, sir.
So then we can square both sides, and by squaring both sides, we end up get y is equal to a quarter y squared, don't it?
Yes.
And then this is a baby equation now, multiply through by 4. So multiply through by 4, we're going to end up get 4y is equal to y squared. Then we can bring the 4y over here. So now to get this can become y squared
minus
minus
4y
4y
is equal to
equal to
0.
0. Yeah, then we can factor out y. So we can end up get y
Y
times
times y minus 4 is equal to
equals
0.
0. Yeah, man. And then it turn baby equation. Because now either y equal 0 or, so y equals 0 or y equal 4, right?
Yes, sir.
But then what was y? Y was log to base 2 of x. This is log to base 2 of x. So log to base 2 of x is 0 or log to base 2 of x is 4. This is where we're going to need to remember the definition, Marika. Now, if the log of a number is 0, so remember it is base to the power equal x. So that means 2 to the 0 equal to x. So what we're telling you then, Marika, is x equal 1. Over here, we're saying that 2 to the power 4 is equal to x. That's the definition of logarithm. And so we're saying x equal 16. So x can either equal 1 or x equals 16. Right? Nice, don't it?
Yes, sir.
Nice. So of course, you know, we love to verify things with our calculator. So I'm just gonna take out the calculator. I'm gonna verify it. So we got x equal 1 or x equal to 16. And the calculator, which is our friend, is gonna prove us right. So if we had the square root of log to base 2 of 1, that would be 0. And if you check out the left-hand side and work out log to base 2 of the square root of 1, sorry, we still get 0. So sister, 1 is a solution, right? Then now, let's check out 16, Marika. So if we have log to base 2 of when it is 60, we're going to get the answer going to be 2. So we need over this side to be 2 too. So can we check it out? Log to base 2 of the square root of 16. We're hoping we'll get 2 so it balance. So we'll get 2 there. So this is so nice. When x is 1 and x is 16, we'll get the same answer upon the left and the right hand side. So call it this.
Yes, sir.
All right, now the last part now give us a modulus equation to solve a modulus inequality. So it end up tell we say x squared minus the modulus of x minus 12. They're telling us to solve this to be less than 0. Is it less than or greater than? Yeah, less than 0. So now, Marika, this is where we're going to need to remember that the modulus of x being squared is equal to x squared. We have to remember this identity. The modulus of x squared is equal to x squared. So right here, so where x is, we're going to replace x with the modulus of x squared minus the modulus of x minus 12 less than 0. Then we can factorize it. Let's factorize doom, doom, less than 0. So right here, so we're going to get the modulus of x. And right here, so going to be the modulus of x. Now this, remember, means signs are different and the bigger number negative. Which two number we times them will get 12, but add them will get negative 1. That look like 4 and 3. So I'm going to put 4 here and 3 here. But the negative is associated with the 3. I'll put the minus here and the minus here. So what this is telling me, Marika, is that, well, actually, wait, this is plus 3. Now we know that this part won't give any solution because modulus can come out to be negative, don't it? This part is not feasible. This part is not feasible. You can say not feasible, not applicable, not realistic, not possible. You can tell them that's crazy. Anything you want to tell them. But no, this can happen in real life. The modulus of a number can come out negative. So now we're going to focus on this part that end up till we say the modulus of x minus 4. That part right there is less than 0. So this is telling us that the modulus of x then is less than 4. And if the modulus of x is less than 4, this is telling us that x is between 2 and negative 2. X is between 4 and negative 4. We're cool with this?
Yes, sir.
All right, always remember that is what that means. So always remember, if you have the modulus of r is less than 1, then it is telling you that r is between 1 and minus 1. All right, and the only reason why we can dash with this part is because this part now is feasible. You're gonna get mod x is less than negative 3, or the modulus for less than a negative number. That's crazy. So x have to be between 4 and negative 4. For example, if x is 3, the modulus of 3 is 3. 3 minus 4 is less than 0, so that's possible. So if you were to put in a number like 3 squared, right? Let's say you're trying 3. If you try like a number like 3, you have 3 squared minus the modulus of 3 is just 3 minus 12. This would give me 9. Minus 3 is negative 6. 9 minus 3 is 6, and 6 minus 12 is negative 6, and that is clearly less than 0. So for any number that is between negative 4 and 4, that will satisfy this inequality. So that's what we're going to put here, that x is between 4 and negative 4. We'll call it this. Call it this, Marika. Are we cool, Marika? Can you hear me? Can you hear me, Marika? Can you hear me?
Hi. Oh, you're coming. No,
Can you hear me?
you miss me when
Hello, Marika. Hello.
Oh, sorry, sir. I couldn't hear you properly.
Can you hear me now?
Yes.
Okay, I was wondering what happened. All right, nice. So that's question 1. All right, now Marika, this is the reason why I want you to remember. I want you to remember the sum and product of roots, because they always ask it sometime. Look at this now. They said the quadratic equation x squared minus px plus 24 equals 0. Express in terms of p, the two roots, alpha plus beta. You see, coming in here, we have to remember that alpha plus beta is minus b over a. See why we have to remember them now? You see it, Marika? So in the previous question, in question 1, we remember alpha plus beta equal minus b over here. It's good to remember it because you might have other questions that you might need to know it anyway. So
Yes.
you don't have to always use the factor theorem. All right, so we have x squared minus px plus 24 equals 0. And they want us to first find alpha plus beta. So now, Marika, you have to remember that alpha plus beta is the sum of the two roots, and the sum of the two roots, alpha plus beta, is minus b over a. So in this case, it's going to be equal to p over 1. That's alpha plus beta. So alpha plus beta work out to just be p, right? Alpha plus beta is P. Cool it this? You cool it this, Marika?
Yes, sir.
Now the next part asks us for alpha squared plus beta squared. I find that persons always find it difficult to remember the formula for alpha squared plus beta squared. So again, I'm just going to show you where it stems from. Marika, if they want alpha squared plus beta squared, let's say we don't know how to find that. It stems from this formula. If you were to, you already know alpha plus beta, right? You know this is P. So if you were to square this, you'd realize that alpha plus beta square is equal to first term square plus twice the product of the two plus the second term square, don't it? Right, Marika? Call it this? Right, Marika?
Yes, sir.
So if we were to subtract 2 alpha beta from both sides, we'd end up get alpha plus beta square. We'd end up get alpha plus beta square minus 2 alpha beta. We'd end up get that this is equal to alpha square plus beta square. You agree with this?
Yes, sir.
So now right here, so we can just tell him say alpha square plus beta square is equal to alpha plus beta all square is equal to alpha plus beta all square minus 2 alpha beta. Agreed?
Yes, sir.
So now we already know alpha plus beta. Alpha plus beta is P. So that's P squared minus 2 times alpha beta. But this is where we have to go back. I remember say alpha beta is C over A. That's 24 over 1. Alpha plus alpha beta, Marika, is C over A. So this is going to be 2 times alpha beta is C over A, which is 24. All right. So this works out to be P squared minus 48. That's alpha squared plus beta squared. All right. They're not asking anything at all. It's just to remember some little bit of formula. That's P squared minus 48. Then here what they say for part 3 now. Given that alpha squared plus beta squared is 33, find the possible values of P. Marika, them couldn't ask for nothing easier. Them tell us that alpha square plus beta square are 33. So just set this equal 33 though. That not nice. That nice though.
Yes, sir.
So set this equal 33. So we can carry over the 48 to get P square equal 48 plus 33, that's 81. And then we'll square root both sides, we get P is equal to 9 or P is equal to negative 9. Remember, when you square root a number, you get plus or minus. So P is equal to 9 or P is equal to negative 9. And it's that easy. All right, so see it here, we can write possible values of P. That's why they say values. You get P equal 9 or P equal negative 9. Couldn't be any easier. Nice. Now, Marika, let's look at this function that they give us now. They're giving us a very weird looking function. They said that the function f of x has the property that f of 2x plus 3 is equal to 2f of x plus 3. And we need to find f of 3, f of 9, f of minus 3. All right, so let's go ahead and do this. It looks pretty weird. Let me get rid of this. All right, I'm able to copy now. We need to find f of 3, f of 9, and f of minus 3. So let's go ahead and do that now, Marika. Let us have some fun. All right, so part 1, find f of 3. Part 2 was to find f of 9. And part 3 was f of minus 3. So let's go ahead and do this now. So Marika, look at this now. How do you think we're going to find f of 3? Now, Marika, look at this. Look at this. Let's say f of 2x plus 3.
Would be 2f of 0 plus 3.
Very good. So plug in x as 0. So first thing, Marika, if we sub in x as 0, we can say, so boops, plug in x as 0. So we're going to end up get f of, put in x as 0, we're going to get 2 times 0 plus 3, we'll put x as 0, and that going to equal to 2 times, remember we'll put x as 0 to get f of 0 plus 3, don't?
Yes, sir.
But then 2 times 0 is 0, so that just left we back with f of 3. But then now we know say f of 0, f of 0, 6. So end up get 2 times 6 plus 3. So that's a 12 plus 3, which are 15, though. What kind of easy question that nice, though? Right?
Yes.
Now we need f of 9. What do you think we're going to put as x to get f of 9?
2.
2, very good. If we put x as 2, we're going to get f of 2 times 2 right here. You said 2?
And x is equal to 2.
You put x as 2, but 2 times 2 is 4. 4 plus 3 is 7. Try again.
Sir, what number are you trying to get again?
F of 9. 9 we're trying to get.
But if it's...
If it's 2 here, so you get 2 times 2 is 4. 4 plus 3 is 7. So we need this to be 9. What can we put for x to get 9?
3.
3. Yeah, man. So see it there, man. So f of 2 times 3 plus 3, that can give you the f of 9 over there. So this can be equal to 2 times f of 3 plus 3. Right, so over here, so now we're going to give over f of 9, but we already know what is f of 3. So this is now 2 times f of 3, but f of 3 is 15. So this is 2 times 15 plus 3, and that works out to be 30 plus 3, which is 33, right?
Yes, sir.
Nice. Now, let me see if you're thinking now. We need it to be, we need f of negative 3. What can we do, Marika?
And we need to get negative 3.
So what can we do to get negative 3? Just plug in negative 3. Yeah, just plug in negative 3. That nice. So we're going to end up get f of 2 times negative 3 plus 3. And that's going to be equal to 2 times f of negative 3 plus 3. Now prove that one is nice now, Marika, because look at this. Boom. 2 times negative 3 is negative 6. Negative 6 plus 3 is negative 3. So we get f of negative 3 equal to 2 times f of negative 3. Plus 3. So Marika, if we stay so now, and bring over the f of negative 3 over here, and bring the 3 over there, we're going to carry the 3 over here so to make it become negative 3 equal to 2f of negative 3 minus f of negative 3. Yeah. But f of negative 3 minus f of negative 3 is just f of negative 3. So end up get f of negative 3 equal to negative 3, don't?
Yeah.
Agree with that? So if f of negative 3 equal to negative 3, we're done. So the first one we get 15, then we get 33, then we get negative 3. That easy. Nice. So we get 15, 4 marks to the nothing, 33 to the nothing, negative 9, negative 3 to the nothing. Nice. Now this question here now, Marika says, prove that the product of any two consecutive integers, k and k plus 1 is an integer, then prove by induction that n times n squared plus 5 is divisible by 6 for all positive integers. Now, Marika, as we can see right here, let me take a second. Remember, we always used to talk about the product of two consecutive integers is an even integer and all of them things. Let's see it coming back to play here. Is this how we need to know it? Yeah, man, them they on past paper. Right, Marika? Right?
See.
All right, so let's tackle it now. So now prove that the product of any two consecutive integers is even. So first thing, Marika, we have to start with is if k is odd. If k is odd, Marika, then we know that k is equal to 2 times some number t. And if k is odd, then k plus 1. If k is odd, sorry, k is 2k plus 1. And then that would mean that k plus 1 is even. And if it is even, and if k is 2t plus 1, then k plus 1 would be equal to, in this case, 2t plus 2, right? Right, Marika?
Yes, sir.
So if you multiply k times k plus 1 now, Marika, what we're doing is, this is going to be 2t plus 1 multiplied by 2t plus 2. Now all we have to do is expand the brackets. Expand, expand, expand. We're going to get 4t squared. Then this times this is going to give it plus 4t plus this going to give it 6t. And then 2 times 1 is 2. Now, Marika, we can factor out 2 and write it as 2 times in bracket 2t squared plus, this would be 3t plus 1. But 2t squared plus 3t plus 1, we can call this number m. So it's equal to 2 times m. But once I get 2 times some number, that is even. So hence, k times k plus 1 is even. Now, Marika, we need to check out now, what if k did even? We started with if k is odd. Let's look at if k is even. If k is even, Marika, then we know that k is equal to 2t. And so k plus 1 would be equal to 2t plus 1, right?
Yes, sir.
So now we can multiply them and then tell them, say, okay, k times k plus 1, that would just be equal to, we expand the brackets, that is k squared, wait, sorry, we don't need to expand that part, k times k plus 1, k is 2t, multiplied by k plus 1, which is 2t plus 1. So we'll work out that now, 2t times 2t is 4t squared, 4t squared. And then 2t times 1, that's plus 2t. All right, then we can factor out the number 2, Marika. We'll factor out the number 2, we end up get that it is equal to 2t squared plus, that's now just t. We can call 2t squared plus t some number q. So that's 2q. All right, so k times k plus 1 is 2q. And so hence, k times k plus 1 is even. All right, hence k times k plus 1 is even. Cool with this?
Yes, sir.
Nice. So that's it, Marika, that's it, that's it. Now the induction part, we're gonna breeze this up. Let me say prove that n times n squared plus 5 is divisible by 6 for all positive integers. So we need to prove that n times n squared plus 5 is divisible by 6. So we need to show that this is divisible by 6 for all n, where n is a natural number. So first, Marika, will start with step 1. we let n equal to 1. If we plug in n equal to 1, Marika, we're going to say we're going to get 1 times 1 square plus 5. And that's going to give way 6. But 6 is divisible by 6 because 6 is just 6 times 1. If you divide 6 by 6, you get 1. And so therefore n equal 1 is true. Nice, n equal 1 is true. Since n equal 1 is true, Marika, we can go to step 2. And I just rhymed. Nice. So now we can let n be equal to k. If we let n equal k, Marika, we're going to get k times k squared plus 5. Now, Marika, what we're going to do is we're going to assume this is true. So we're going to write that is equal to 6 times m. M for Marika. Yeah, man, use up your letter. Don't put x. Everybody going to use x. We're going to have to tell them where m is an integer. M have to be an integer, and we can tell them, say, we assume n equal k is true. Pull it this. Cool so far, Marika?
Yes, sir.
Now here's the nice step now for n equal to k plus 1. For n equal to k plus 1. For n equal k plus 1, Marika, what we're going to have is k plus 1 for n. So that's going to become k plus 1 times, in this bracket, it's going to be n squared is now k plus 1 all square, k plus 1 all square plus 5. All right. Now let's see how we're going to simplify out this now, because we know that we're going to have to expand and simplify down. So first thing now, we know we need to expand out this bracket. So we're going to expand out that bracket to write k plus 1, and this is being multiplied by, in here, so now would become k squared plus, this would be 2k. Twice the product of the 2 is 2k plus 1 plus 5, right, Marika? Right? Cool it this? Write the 5 a little better. Agree with this?
Yes.
Now we're gonna multiply k times everything. Now, Marika, look what I'm gonna do, you know. Follow keen attention. I'm not gonna actually call it k squared blah blah, k cube blah blah blah. What I'm gonna do is I'm just gonna put k times in bracket k squared. Now look what I'm doing now in America. Instead of writing it in this order, I'm gonna put the 5 first. K times k squared plus 5 plus, it's k times k squared plus 5 plus 2k plus 1. All I did was rearrange them. Did you see that all I did was rearrange these? You see it? 2k plus 1 plus 5, 5 plus 2k plus 1. Those are the same thing though. I just rearrange the order, right?
Yes, sir.
Then plus 1 times everything, right? That's how we expand the bracket now. Plus 1 times everything over here, so, which is 1 times k squared plus 2k plus 1 plus 5, right, Marika? Right?
Yes, sir.
All right. So now, Marika, you might say, so sir, why you do all of that? Why I did all of that? Because I want to write k times k squared plus 5 and 6m. We said that. So that part here, Marika, we're going to write that part as k times, in bracket, k squared plus 5, because that's going to generate our 6m. And then over here, so now we're left back with k times the 2k plus 1. So we can just write plus k times 2k plus 1 now, Marika. We can expand the part there and write it as k times 2k is 2k squared plus k times 1 is just k. Then, Marika, we can keep on adding 1 times k squared. That's just plus k squared. Then 1 times 2k, that's just 2k. So we can put plus 2k. And then we can keep on adding and say 1 times 1 is not a plus 1, plus 5. Or we can even write 1 plus 5 as 6 now, right? 1 plus 5 is 6, right, Marika? Right, Marika?
Yes, sir.
Now, we're going to write everything now and say, but wait, that part here from over there so was 6m. Then this part now we're going to simplify as 2k squared plus k squared, that is 3k squared. And then we have k plus 2k is 3k plus 6. Now, Marika, follow where the math's gonna go now. Now, remember around here, we said that k times k plus 1 is even. You might say, sir, what does that have to do with anything? Well, Marika, right here, so we're gonna end up, say for n equal k plus 1, we're getting 6m plus, you see this 3k squared plus 3k, Marika? We're going to factor out 3k. Because if we factor out 3k, we only end up get 3k times k plus 1. Then we're going to have plus 6. You agree with this? All I did was factor out 3k right here. So that part here, rewrite it as 3k times in bracket k plus 1. You agree with this?
Yes, sir.
But Marika, but wait there. Wait there. K times k plus 1 is what? We said that is even. But how do we express an even number? As 2t, no? Right?
Yes.
Box cover, that's sweetie. We just put 3 times 2t, that's sweet, man. That's sweet. Yeah, man, sweet. So now, Marika, we expand 3 times 2t. We end up get 6m plus 6t plus 6. Yeah, man, it nice. Then now we can factor out 6 now, Marika. I'll end up get m plus 1. Well, m plus t plus 1. And you can write all of this as some number q, which is 6 times q. So we can say hence n equal k plus 1 is true. Hence n equal to k plus 1 is true. Agree with that? Agree that, Marika?
Yes, sir.
Nice. So since n equal k plus 1 is true, our nice, Marika, oh good. So we can just conclude, hence, n times n squared plus 1, we can tell them this is divisible by 5 for all natural numbers. Cool with this, Marika?
Yes, sir.
Nice. And that's it. Can tell them this. Cool? Yeah, man. All right. So we're nice.